All right, section 3 in polynomials is adding, subtracting, and multiplying. And it's algebra 2, so we're getting a little more complicated, particularly when it'll come to multiplying, and then the next section, which is factoring. So there's a couple ways you can go about this. You can do it horizontally. We're looking for like terms. Essentially, the parentheses don't really matter. I mean, if I told you to do 3 plus 5 plus 2 minus 6, addition and subtraction, doesn't matter what order you do it in. You can actually ignore the parentheses. And you could even do 3 minus 6 first, then plus 2, then plus 5. So essentially, these parentheses don't really matter. It's just that this is a polynomial and this is a polynomial, and I'm adding these two polynomials together. But basically, we want to add like terms, and remember there's really a 1 out front here. So a 2x cubed plus a 1x cubed is a 3x cubed, and it's good to think about it in order. And then, so I'm going from the cubes to the squareds. A negative 5x squared and a positive 6x squared. So this is like saying I have 2 apples plus 1 apple is 3 apples. Now I have 6 oranges and I'm taking away 5 oranges, so I still have 1 orange. If you want to put the 1 in there, you can. 3x doesn't have a partner or a like term, and then a negative 9 plus an 11 would just be a plus 2. So you can do it horizontally if your brain works that way and you can see the like terms. Some people like to cross them out as they go through them. That works too. I'm not going to do that here as an example just because then I'll lose you in the next part. But another way to do this is vertically. So here is this polynomial. And again, it goes back to some of those prior things we were talking about in terms of keeping everybody's place. So here's my x cubed, my x squared, my x to the first, and essentially my x to the 0. And then when I come over and I'm adding this, I do have an x cubed term. I do have an x squared term. I don't have an x to the first term, and I do have a constant. So now everybody's in their place, and a 2x cubed plus a 1x cubed is a 3x cubed, x squared. So vertically is pretty nice, keeping everybody in line. If it's a little harder for you to see it horizontally. This is an addition. Yeah, so another addition. Let's think about this again vertically. So I have a 3y cubed minus a 2y squared minus a 7y, and I'm going to want to keep that constant's place. There is a plus 0 here, and then I'm going to add, and this is a negative 4y squared, so it's going to go directly underneath there, plus a 2y minus a 5, and since this is addition, it's relatively easy. So yeah, that works pretty nicely. Now subtraction is always a little trickier. Did I raise that up enough so you guys could see that? I think so. Subtraction is often a little trickier because we have to remember it's almost like there's a negative 1 out front here, so you're distributing that negative. I'll do it horizontally again, so I'd have an 8x cubed minus a 3x cubed. That would be a 5x cubed. And then I have a negative 1x squared minus a 2x squared. So that would be negative 3x squared. Then I have a negative 5x minus becomes a plus 1. So a negative 5x plus a 1x is a negative 4x. And then a positive 1 minus a 7 would be a negative 6. So again, if your brain works that way and you can do it without error, that's awesome. Otherwise, you can work vertically. And I have a cubed, a squared, x to the first, x to the 0, and I'm going to subtract. And whenever I'm subtracting, I like to put the entire quantity in parentheses. And again, depends on how your brain works. Subtracting is like adding the opposite, so I could change everybody's sign here. I don't like that because it's sort of hard to see, but now I have an 8x cubed minus a 3x cubed. And I have a negative x squared and a negative 2x squared, so that's a negative 3x squared. And a negative 5x plus a 1x is minus 4x, and a plus 1 minus a 7 is a negative 6. Somewhere along the way, someone taught you to add and subtract. Let me see how that would look again. I don't normally do the change sign thing because I can think about it. This is what it looked like before. But I recognize everybody's brain is a little bit different. So here's how I normally do it. 8x cubed minus 3x squared. 3x cubed is 5x cubed. A negative x squared minus a 2x squared is minus a 3x squared. A negative 5x minus plus negative 5x plus x is negative 4x. And a 1 minus a 7 is minus 6. And then we'll do just one more. And you know what? Z's, S's, B's, sometimes they're all confusing. I think I'm just going to change them to X's. And then I'm going to subtract. And a 4x squared minus a 5x squared is a negative 1x squared. This minus becomes plus. And negative 12 minus 3 is minus 15. Okay, multiplying. Now, multiplying polynomials is really just about distributing. We all learn, to distribute x times x plus 3, x times x times 3, so I get x squared plus 3x. Or you guys remember FOIL, x plus 2 times x plus 3. Sorry, x times x is x squared, x times 3 is 3x. FOIL is just distributing in a particular order, which actually I think is an order that makes sense. First, outer, inner, last, which to me is just distributing this guy to both things, first, outer, and then this guy to both things, inner, last. So you get an x squared plus a 3x plus a 2x, and then plus a 6, and then these two terms combine. You get x squared plus 5x plus 6. FOIL, really just the distributive property. And so when I look at this, I would prefer to write it like this. It doesn't matter. Oh, here we go with the y's again. But I just like the idea of distributing two things versus distributing three things to two. This order makes it a little easier for me. So y times negative 2y squared is negative 2y cubed. Y times 3y is 3y squared. And y times negative 6 is negative 6y. And then I'm going to distribute the negative 2. So negative 2 times negative 2y squared, and watch what I'm going to do, is a positive 4y squared. Negative 2 times negative 2 is 4y squared. Negative 2 times 3 is negative 6y. And negative 2 times negative 6 is positive 12. So notice I put them in their place. And now I can add any like terms. So negative 2y cubed plus 7y squared minus 12y plus 12. And if you had just continued to write these horizontally and added like terms, that would be fine too. But basically, you're just using the distributive property to multiply. I don't know. I hope this is in focus. So let's try that again. So x times 3x squared. There's really a 1 here. So 1 times 3 is 3. X times x squared is x cubed. 1 times negative 2 is negative 2. X times x is x squared. 1 times 4 is 4x. I'll do it vertically again. So maybe you'll like it. Again, if you just write these horizontally and you have to combine the like terms, that's fine. But I'm going to do it this way to help you keep it organized. So 3 times 3 is 9x squared. So that's going to go down here. 3 times negative 2 is negative 6x. And 3 times 4 is 12. And so when I add all these up, I get 3x cubed plus 7x squared minus 2x plus 12. There I go again. I'm not paying attention to sliding this up. 3 times 3 is 9x squared. 3 times negative 2 is negative 6x. 3 times 4 is 12. Line everybody up. Add 3x cubed, 7x squared, negative 2x, 12. And then what about if I have 3 binomials? I'm going to do, maybe because I like to have one binomial out front, I'm just going to leave that guy out front. Then I'm going to do x plus 1 times x plus 3. So if I FOIL, that's x squared plus 3x plus 1x plus 3. And if you can do that in your head a little faster, that's fine. Go for it, as long as you're accurate. So this becomes x squared plus 4x plus 3. Simplify that first before you distribute again. So now I can just distribute the x to everybody. X cubed plus 4x squared plus 3x. Now I can distribute the negative 5 to everybody. Negative 5x squared. I'm going to put it in order. Minus 20x. Oops. Minus 15, and negative 5 times a positive 3 is a negative 15. Then I have an x cubed minus an x squared minus a 17x minus a 15. And it wouldn't have mattered. I could have done these two first and then multiplied by this one, but do you remember how I told you I like to keep my binomial out front so that I only have to distribute two things rather than the other way around? But it's all just about the distributive property and multiplication in whatever order you want. To do some of the next few, you need to, well, you don't need to know these. They are convenient, and hopefully some of these will resonate from when we did quadratics. The cubics will be new, and that'll be important for when we do factoring. So the only time we ever miss a middle term is when the outer and the inner cancel. So an a plus b times an a minus b results in an a squared minus a b squared. So think about it. Suppose I have an x minus 3 times an x plus 3. What happens? X times x is x squared, and then the outer is a positive 3x, the inner is a negative 3x. They cancel, and then I would do negative 3 times positive 3. I get a minus 9. So there's an x squared minus a 9. So that is technically x squared minus 3 squared, right? But what happens if I had an x plus 3 times an x plus 3? Then what happens? I get an x squared, and my outer term is a plus 3x, my inner term is a plus 3x, and then I get a plus 9. Notice they don't cancel. That is why x plus 3 squared is not equal to x squared plus 9, people. Never is going to happen, because you're going to have an outer and an inner term. Oops, I wrote that over here. That is why x plus 3 squared is not x squared plus 9. So you get an x squared plus 2 of these. I have 2 3x's. So that's x squared plus 6x plus 9. And that's what this is trying to tell you, that whatever it is, an a plus a b squared is going to be, so if I have an x plus a 3 squared, that's going to be my a squared, plus 2 times these guys multiplied together, which is going to give me 6x, plus your b squared, x squared plus 6x plus 9. Same thing when you subtract, except in this case, your outer and your inner term are both negative 3x's, so you're going to get an x squared minus the 3x minus the 3x, and then the negative 3 times a negative 3 becomes a plus 9. So again, there's that 2 times your 3 times your x. So if I have an x minus 3, that's an x squared minus 2 times my negative 3 times my x. Sorry, times my 3 times my x plus my negative 3 squared. X squared minus 6x plus 9. Now here's the thing. I don't really, these are not important to memorize. I mean, they help you factor and do things quicker, but FOIL will never fail you. If you take your time in FOIL or distribute, you will always get it right. So while these special patterns are nice, they are not essential. But I am going to take you through the special patterns of cubes. This video is going to be long. I'm just going to go for it. Then you'll just have one to watch. So the special patterns of cubes work like this. Something plus something cubed. Really, remember, that would actually mean p plus 2 times p plus 2 times p plus 2. And sure enough, you could FOIL and get this all right. FOIL these two guys, then distribute one more along with that. But there is a pattern here. A cubed plus 3a squared b plus 3ab squared plus b cubed. So this is your a, and this is your b. So your a is a p, and your b is a 2. So if I follow the pattern a cubed, what's my a? A p. Plus 3 times my a squared times my b, which is a 2, plus 3 times my a times my b squared plus my b cubed. A cubed plus 3a squared b plus 3ab squared plus b cubed. And then you could simplify. P cubed plus 3 times 2 is 6, plus 3 times 4 is 12, plus 8. So if you can follow the pattern, that's great. If not, FOIL along. I'll write the pattern here. It's an a minus a b cubed remember, it's my job to kind of expose you to things, so this is what we're going to do. So again, our a is a 3x, right? And our b is a 4. So I'm going to do a cubed. Now here's, you have to be careful. A is 3x. I need to cube that whole thing. Minus 3 times my a times my a squared times my b plus 3 times my a times my b squared minus my b cubed. So just plug everything in. My a cubed minus 3 times my a squared b plus 3 times my ab squared minus my b cubed. There's a whole series of these, the binomial theorem, and it goes with Pascal's triangle, and it's kind of cool, and you'll learn it later. But now you have to simplify. So 3 cubed is 27x cubed minus 3, and I'm going to be deliberate, 3x, the quantity squared, that's 9x squared, plus 3 times 3x times 16, that's going to be 64. So 27x cubed. 3 times 4 is 12. 12 times 9 is what? 99 plus 9, 108. Is that right? Plus 3 times 3 is 9. 9 times 16 is 160 minus 16, which is 144. That can't be right. I left my calculator somewhere else. I'm just going to go with it. 144x. 16 times 9 is 54. Carry the 5. Sure enough. Minus 64. Okay. So that's using that cubic pattern if you can. Again, if not, just go ahead and use your distributive property. All right, so quickly, a couple more, just to make sure we're in good shape. So I'm going to subtract 4x, I'm going to call them. These other variables are kind of annoying. Minus. So a 4x minus a minus becomes a plus. Whoops! I wrote that in the wrong line, didn't I? Because I'm trying to... be quick about this, which is not a good thing. 4x cubed minus 11x squared plus 4x plus 0, I'm going to keep everybody's place, minus a negative 7x squared minus a 5x plus an 8. Okay, so 4x cubed minus nobody is 4x cubed. Negative 11x squared minus minus becomes plus. 4x minus minus becomes plus. 0 minus 8 is negative 8. And here's a fun one. We have a 3 times a 3. So I'm going to distribute my negative x squared first. And I'm going to get, that's a negative 1. Negative 1 times 3 is negative 3. And x squared times an x squared is an x to the 4th. And negative 1 times a 6 is a negative 6. X squared times x is x cubed. A negative 1 times a negative 5 is a positive 5, x squared. Now I'm going to do 4x. 4 times 3 is 12, x cubed. So I'm going to put that in the x cubed column. 4 times 6 is 24, x squared. 4 times negative 5 is negative 20x. And then I'll do 1. 1 times 3x squared is 3x squared. Put it in the x squared column. 1 times 6x is 6x. 1 times a negative 5 is a negative 5. So who do we have for x to the fourths? Just a negative 3x to the 4th. I'm going to end up with a positive 6x cubed. 29 plus 3 is 32, x squared, minus 14x, minus 5. So distribute. I think if you are a fan of horizontal, in this case you start to see the benefit of the vertical. But if you keep it horizontally, again, like you would just have one long line of all these guys, and you'd have to just make sure, again, lots of people like to kind of cross them off as they combine the like terms. All right, that was a long video.